Hey guys, welcome to the video. We are still talking about these vases, which may be good news to some of you, but also maybe boring to others. But yeah, so the last video was pretty interesting. Got some good feedback. There was a lot of good comments in that video. I'll actually just show you some of them. But yeah, overall, we got really good feedback, really good engagement. It's one of my best performing videos, so I really appreciate all of you guys that watched. Overall, the comments really good. We had some people, some machinists commenting, kind of clarifying what I'm saying, but maybe putting it a bit more concisely together, because sometimes I can't really articulate what I'm trying to think and say whilst recording. I actually find recording quite difficult, and speaking to camera, that's quite difficult, but I appreciate people kind of typing out good, written, clear understanding of how they perceive these vases to be made, and I really appreciate that. So if you haven't checked out the previous video, check it out. It's kind of me discussing Flint Dibbles' take on these vases, the ancient Egyptian vases, which are made of very high precision, and Flint Dibble, an archaeologist, has a theory as to how they're made, but unfortunately he kind of states it as fact, this is how they're made, where I kind of believe the evidence he suggests doesn't kind of prove what we have in front of us after these vases have been scanned. The data doesn't reflect his theory on how these were made. And that's kind of my thing, we don't know how these were made. I think if Dibble kind of said, you know what, we don't know, they're highly precise, but let's do some more research to find out, I think everyone would be way more accepting and way more happy with that answer, as opposed to saying they were spun. Well, I might actually insert the clip, this is how Dibble says they were made.
Tomb paintings that show how these are being made with a drill that you rotate around. And so with a flint drill bit and stuff like that. Well, you put something in and then you attach it. So there's a wooden thing going in and you attach the drill bit on it so that it circles around. If you're making
wood?
The thing you're spinning is wood and stone is attached to it.
So there's they put
the lever. Let's go back to those tomb paintings. They show them best.
So in this video, I want to outline a few of the different processes that could be used to create these vases. So I'm going to look at some kind of modern techniques as well as some older techniques, and we'll just go through them and do some research and just see what conclusions we can take from looking at this. We're going to look at some videos and we can discuss. But yeah, again, thank you. I really appreciate all the comments in the last video and the engagement and the subscribers. Yeah, so this is a really cool video of a guy turning a granite cup. So this will give you an idea of how we could do something like this in today's world. So using machinery, modern techniques to create something not too dissimilar from what we see from the past. Obviously, we're using heavy machinery here. So this is obviously a some kind of saw, a chop saw, and the teeth on this saw will probably be some kind of hardened steel, not made out of flint. So he's initially cutting the kind of general profile of the vase. So this is what you tend to do. You kind of rough it out of how you want it to look. So then you've got the kind of overall general dimensions, and you'll see how he actually attaches it to the lathe. So here he's just marking off, I think probably the estimate of the center, it looks like. Okay, I'll take that back. He's actually cutting a section so he can fit it into his chuck. I think that's called a chuck. And now it's going into his lathe. So this is a lathe. If you don't know what a lathe is, this is what it is. It's there's different types of lathe. Some are bigger, some are smaller. But essentially it just spins your, whatever material you want to work with, it spins it at a high velocity. And it's very stable. Lathes are super stable. They're massive, heavy bits of machinery. So they don't kind of move, essentially. So it means when you're cutting it, it should be dead consistent. When you're cutting the material, you should have, you can be sure that it's true and level and it's not going to wiggle off the bit. So it looked like there he was kind of just cutting away some of the pieces, some of the larger pieces, again still trying to get that form together. This doesn't look very safe, to be honest. I'm sure he knows exactly what he's doing, but this looks a bit rogue. So yeah, you can see it's spinning at such a high speed there, the piece of granite, and he's just using the tool to kind of cut away at the granite and get a kind of a smooth edge. And again, he's using some hardened steel blade to kind of cut away at the granite. And you can kind of see the profile he's created now. You can see the etches. You can see the etches from the blade. You can see those kind of like diagonal edges on the piece of granite itself. Now it looks like he's getting some kind of Dremel. And they are probably some really hard bits. So the bit is the thing that actually does the cutting. And that's going to probably be polishing and just smoothing out all those edges. So look, you can see now it's a way smoother piece of granite. So now it looks like he's going to start work on the kind of inner section, so cutting away the inner hole for the vessel. And he's using a Dremel, and again he's using his lathe. And now he's probably going to put, so he's putting almost like a hole saw bit in his lathe, so he can bring bring the bit to the spinning workpiece, and it will cut the hole through the piece of granite. So like he's doing now. So he's getting smaller and smaller on the bits. Maybe that's to, remove the central mass, more easily. So yeah, now he's chiseling it out. Makes sense. So he's removed a lot of material there quite quickly. So look, he's got a huge hole in there now. So yeah, this is kind of a great example of how you cut granite on a lathe. He's using all the modern techniques that we would use and modern tools. And you can see he's done it really quickly. Now, the only issue with this is just like a cylindrical shape, a cylindrical profile. But with our vases, what we have is the issue of the lug handles, whatever they are, because I'm still not convinced they're handles. They're so small. It's not designed to be like ergonomic. So obviously you can't turn the handles. You could turn you could have leftover material for the handles, but you couldn't actually finish the handles with this process. And look, he's got an amazing shine on that. That is really impressive. Now he's probably just smoothing out the inside of it. It's working down the grits, so you get higher grits will mean more, a finer finish essentially. So it's going to be more and more polished, more and more smooth. So you get that kind of shiny, reflective property. He's using a pencil and a bit of sandpaper, which I like. But again, he's using a lathe, right? So this is spun consistently at a high speed. He's now cutting it. And there you go. Now he's going to finish the bottom, probably with the same kind of Dremel he used. So that's a really high speed Dremel. So that little bit on the end is spinning really fast. If that's not clear. But he's just cutting away material. Okay, let's just skip. So that's it. That's the finished article. I mean, yeah, that's cool. Really cool. But you saw how he turned it with a lathe. Obviously, we're missing our handles, which is actually a key component of the vases. Like the handle part is almost where a lot of the mystery comes from. I think if the vases were perfect and just cylindrical like this, it would be way easier to explain with, like some kind of old lathe. But still, the tolerances are still really impressive. But I think, the fact that the vases from the ancient vases have handles means that a process like that would have to be used in conjunction with another process. So I'm going to look into that now. Let's look at like a 5-axis CNC machine and see, if that's a possible use case. So here we show an example of a 5-axis CNC, and this is actually cutting into stone. I'm not sure quite what the stone is. I don't know how hard it is, but it looks pretty substantial. And what's cool about this video, it outlines the steps in which a CNC machine will take in order to create this. So I'll just play it here and you'll see this little bit. So this is the programming of the CNC. So this is what tools are going to be used and how it's going to create this profile of it's called the lady. So it's like a bust sculpture of a lady. And this is just the software showing you what tools it's going to use and how it's going to do it. So it means there's probably a 3D model made somewhere, and the 3D model is uploaded, and the program will work out how it's going to create that out of the given amount of material that you input into the CNC machine. So this is kind of running a simulation essentially of how the CNC will work. So it's removing material and then goes over with a finer piece to create the detail. And this is the finished result. So this is a 5-axis CNC machine. It's a massive bit of kit. I mean, they do come in different sizes, but this one's huge. And what you can see is this can create profiles in all directions. So it's not just like a a two-dimensional lathe where you can only create a round profile. This can create profiles of anything essentially. If you set it up right, you can create most shapes within it. Obviously, you're going to have, you know, limits to what you can do based on the kind of the size of the machine and, you know, the bits. The bits will only be able to go so small and so detailed. But so this is an example of a 5-axis CNC machine. So with this technique, we could create our vases. We could create the vases and they would include the lug handles. Unlike the lathe, this would be able to produce something that had lug handles. And then it could be hand finished, hand polished to get it smooth. And it should yield, you know, really high accuracy results. Now, this is where I'm unsure, like, would something like this produce the same results as the scans in terms of tolerances? Like, are we going to get down to a thousandth of a millimeter of true, a true circle? Are we going to get to that point? I'm not sure. And that's where I think, like, we need more discussion. And I would really advise, or really, you know, like to see from Matt Beall and UnchartedX and whoever's in this space, if they could fund to go try and replicate one of these, I think it would be a really interesting video. A video in which they go to a manufacturer and say, I want to make this. How will we go about doing it? So go to a stoneworker. How do we go about doing it? How much is it going to cost? What are the processes? And then once they do that and go through with it all, you know, using the similar materials to the old Egyptian ones, then we can actually take measurements off that vase. And I think that would clear up a lot of, you know, confusion over tolerances. And maybe it might make us realize, oh, hang on, we can do that today to those high tolerances. Because to me, it's like these tolerances seem so accurate. I'm unsure of how accurate we could get one of these in granite. I know, like, in steel and metal, we can get up to like really high tolerances. But out of a kind of an organic material, I want to know what are our limits, like how accurate can we get it, and whether it's using a, you know, a CNC machine, a 5-axis CNC machine process, or some other technique. I think Matt Beall and well, yeah, I think if they've got the kind of energy to do it and the funding to do it, I think I'd really like to see that, and I think that would kind of help clear up a few of the questions about tolerances and really get people to understand, you know, how accuracy is like kind of measured, and yeah, understand the craftsmanship of it. Right, so we looked at that. Let's look at something else. Here's just another example of a CNC machine. This one's a bit different though. You can see the material is actually kind of rotating at the bottom, and the kind of tool is just moving up and down it. This is quite a cool CNC machine. I'm not aware of these ones. So it's on a big like robotic arm, and you can see the layers being taken away, the layers of material, and you can see the bits. So you can see actually the tool marks. Now this is something also I want to talk about in a future video is scoop marks that we see all over Egypt. I think it's got something to do with kind of tool marks. Essentially tool marks is like where a tool's been and it leaves these kind of patterns, but that's another topic. So yeah, it's just removing more and more layers, and again I think this happens to be a kind of a portrait of a lady, which is convenient. This is obviously out of wood as well, so this isn't granite, this is just wood. Still really impressive, amazing bits of technology there, and it's all done with Cad software to determine where this tool needs to go in order to create what we want to create. It's going over with a finer bit to create the details. You can see the tool and the path, and then it's kind of roughed it out there. So now someone could finish it by hand, get it all really smooth. But another great example of a CNC machine. Here's an example of someone creating something by hand. So this is going to be really cool. Like, you can see the detail they can get. Really intricate details. Now, I don't know what stone this is. I don't think this is going to be as hard as, you know, some of the materials the vase have been used. But what you will find is that, yeah, people can definitely create beautiful structures and beautiful things by hand. But my issue is doing things by hand will always have a kind of organic feel. You won't be able to get a perfect circle or like perfect geometry by hand and by eye. I think that's where like high precision tools have probably been introduced. I mean, we saw the scientists against myths. They spent a long time trying to carve the perfect vase, and we all looked at their results in my previous video. If you didn't watch it, check it out. But you know, it was by hand. It wasn't as accurate as the vases that we've seen. Look at this, a traditional drill. Look how cool that is. Now I think this stone is probably, it's definitely not as hard as granite. This is I don't know the name. This is like travertine marble. Amazing, like amazing craftsmanship. And you know, a lot of people have said, you know, I need to look into this. And yeah, I understand why. Like, because yeah, we can create some amazing things out of marble. But for me, it's about the geometry and the symmetry and the perfectness of these vases. And there's other evidence of this in Egypt as well. There's other like statues that are perfectly symmetrical, which is things that are really hard to replicate by human hand and by human eye. That's where like kind of tools and potentially machinery or something that we don't understand has been used. So I just wanted to jump into CAD just to show you kind of some of the issues that I think we are having with these vases. So these are a few of the scans. These ones were provided by UnchartedX a while ago. In one of his videos, he had some of the scans that you could download, and I downloaded them. What this is the data from the telemetry light scanners, whatever scanners they were using, and it basically builds a net of the surface of the vases. So this is then, you know, collated into a 3D model, and you get this really. So basically a really pretty detailed surface model of what the vase would look like. This one I think is a bit of a higher precision in terms of measuring it. You can see like kind of a bit more of the details on the surface. This one is a bit more basic. It's got kind of simpler geometry, but yeah, I think that's only when you import it. I think when you're measuring it, it provides more detail. So yeah, my issue is, we saw how in the earlier video of the guy turning something on a lathe, you can get this shape. Like, this shape is not an issue at all. Sorry, just the main body of it is not an issue. My issue is with these handles. Like, these handles are the really difficult part of the vases in my mind. So I'm just going to kind of 3D model it for you and show you what I'm talking about. So I'm in some 3D software here. This is actually SketchUp. So first off, I'm going to essentially just draw the profile of what we'd want to cut on a lathe. So if I just draw a rectangle, so it doesn't really matter how big it is, and we're basically going to try and recreate, you know, something close to one of these vases. Let's say the bigger one, just because it's easy. So in order to do that, I need to create a kind of a lip profile, so some kind of lip, and then we are going to have a curve, kind of a curved body. Doesn't really matter how curved it is. And then, did it have a base? I can't remember if it had a base. So it does have a little base, so we can do a little base as well. So if we go to, let's just say it's like that, and then we can have a small kind of base bit there. So essentially that's a profile for our vase. If I now get rid of this, so like the guy on the lathe, you could turn this shape. So if I just draw a circle underneath it, I'll show you what it will look like. So if you turn this shape, you will get a simple profile like this. Now this is not extraordinary. This can be turned on a lathe. We've seen that. Although the guy is using a high-powered lathe with a high RPM, so it's spinning fast, and he's also using hardened steel bits, maybe diamond bits. We're not sure. We can't confirm that. But you know, this is not out of the realm of possibilities. Now the thing is, when you introduce the handles, this is where I think, yeah, it's a lot trickier. So I'm actually gonna, let me just hollow this out so it does kind of look a bit more like one of these vases. So if I just get rid of this. So basically here I'm making the profile essentially just the wall thickness. So if I get rid of that. So that is our wall thickness. Now, let's say we want to add our lug handle. So I'm just going to draw a square here, and then I'm going to do that, and then that. So now this is our profile, right? So this is what we want to cut, and this could be cut on a lathe. But when I revolve this, you'll see what happens. So we have a vase, but we also have this object. So if you were going to turn that shape, this is what you'd get. So let me just show you again. We have our vase, but we need to have these handles. And now these handles, as far as we know, aren't stuck on. They're not stuck on as a separate component. They are part of the integral structure of the vases. So they are, the vase is one piece of material. So you can see where the issue is. Like, in order to create, you know, follow this profile here, and you can see that. So this profile, in order to consistently maintain this profile, you're going to have to remove that material between the lugs, and that is really difficult. And you know, I literally don't know how you do that by hand. So please comment in the bottom, like, that is a bit of a mystery to me. Like, how do you remove that material and maintain like the perfect profile of the vase, if that makes sense? I hope that makes sense. So if we did turn it, we would end up with something like this, and then you'd have to manually remove the material between the lugs whilst maintaining this circumference. Yeah, it's quite tricky. Now I'll show you like how I'd make this, say in CAD, a CAD piece of software. Like I would actually struggle to make this in CAD. I am using SketchUp, which isn't the most, I'd say, like, you can't create the most organic things in SketchUp, but it is pretty good. So this is how I'd make it. I'd actually make it as two separate parts, because to then remove that piece is actually, you know, very difficult. So what I'd do is I'd probably, we can actually, oh, let me just, I'll give it a bit of detail so you know what we're looking at. Let's just curve these edges a little bit. And then I'll put a circle in the middle, represent these small holes. So what I'd do is I'd separate them out. So this is a component, and then this is a component. And what we'd do first is we'd probably, actually, let's explode that. We'd probably revolve the main body of our vase. So let's do that now. Like that. And then, now if I group that, and then I'd do the same thing, but with our handles. Follow me. But I'd probably only do it however wide we need it, like that. So that is kind of a lug handle. It's not perfect. As you can see, it kind of tapers inward, and I don't think, well, we can look, can't we? But I don't think these tapered inwards at all. No, they are like perpendicular. They are like straight. It's like a rectangle has been placed through it almost. But anyway, you get the idea. So that's kind of how I'd create one lug handle. I'd then revolve it around the center, and you'd get a vase vessel. But to me, the biggest mystery is that kind of removing this section here. I think that'd be like very difficult to do. But if you have any ideas, please let me know, because I'm trying to figure this out basically. So that's the vase. Again, like, let me just show you the issue. It would be having this material. So once you turn it, if you say, let's say they turned it on something, whether it's Dibbles' little wooden contraption or something else that we're not sure about, it's then how do you, the second process needs to be like so perfect to remove the material, in the correct places whilst maintaining the curvature of the body of the vase. To me, that is a difficult part of manufacturing, and that's where something like the 5-axis CNC machine, it could do that. You would, you know, do one side at a time. It could do that. A lathe, you couldn't do that. So the lathe wouldn't work for that process. It would work for this part. You could get this part done on a lathe, on something spinning, but removing that other part would be difficult. And it's not to say, I mean, maybe it could just be removed by hand, but just done very accurately. Like that is not out of the question, I don't think. One more thing, I did just want to show you. So here's some of the scans for this vase here. And what you'll see is, look, when we look at the data off the surface, you can see the turning. You can see where a tool has been. So I can zoom into that. Can I zoom into that? No, I can't zoom into that. So here we can see like this vessel down here has been turned because we've got these clear like bands where a tool has removed material. It's not like a hammer where like there's little discrepancies between each area. It's like these are smooth bands, so it has turned. I think we can deduct from that it has been turned. But what's crazy is we've got that same kind of thing between the handles. So between the handles, we have a pretty consistent band of like removal. Also, one thing that I did notice here is this section here at the top, if you can see my mouse, there is a part that's high. I can't remember if this was showing higher or lower. There's a part that is higher on the vase, so like one patch. It's almost like they've missed a patch. But in order to say if it is turning, in order to do that, you'd have to remove the tool. It would turn. It wouldn't be like you've done it. It would literally wouldn't have turned more than 360 degrees to leave that. It's almost like the tool has cut that much off in one turn, and they haven't got all the way around. So this patch is a bit of an anomaly, and I think I might explore that a bit further. But anyway, that's it really. It's a bit confusing. Let me know your thoughts in the comments. This video has kind of gone over some of the techniques that could have been used to make these. And I do really want, like, if anyone knows Matt Beall or UnchartedX, like, we need to actually get one of these reproduced, and I think they should document the process and speak to the machinists and speak to the engineers and figure out how can we replicate one of these in the same material. And I think that would answer a lot of questions, and I'm not sure why that's not been done yet. I think if we can do that, we can make progress on this and, you know, try and get a few more answers. But I think that's it really, guys. I really appreciate the support on the last video. If you enjoyed this video, please give me a like and a comment. It really helps me out. And don't forget to subscribe. I'll probably put out some more videos on this topic because I find it fascinating. I think that's it really, guys. Yeah, peace.